Hi everyone, welcome back. Number 2 with Scalar Projection. Let's see if I can shortcut the process. If you haven't seen the previous one, you can go back and look at it. Let's have a look at this common sense approach. I like to look at it and I go, if I start here, I go across 2 and I go up 3. So that's your across, that's your up. We've got this vector here. I'm going to call it A, which is 2i plus 3j. Other one is 5. 1, 2, 3, 4, 5, and up 1. Rough diagram across to there. That's called vector B. Oops, let's move it out the way. This is vector B, which is 5a plus j. Now we want the scalar projection of A onto B. So you come across to A at right angles to B. Like people say, like you're shining a light down there, but simple enough to understand from that point, come across and make a right angle. We want to calculate this length here, which we can get rid of some of these, and we're just going to call it x. So what do I need? There's two methods. If I know the angle, which I've calculated, it's really nice, I worked out that one to be 45 degrees, I can just go a cosine rule. So I can go, let's watch it, really what it is the magnitude of A by the cos of theta. So this length here, if you want to go back and do the trigonometry, have a look at the previous video. So this length x is the magnitude of A by the cos of theta, and that's one of our ways of calculating the length of the scalar projection. So the magnitude of A is Pythagoras' theorem, which is square root of 2 squared plus 3 squared. So you could have written that as 2 squared plus 3 squared. That's the length of the hypotenuse on that triangle, if you draw up a triangle, times by the cos of 45 degrees. So what's nice about this just becomes square root of 13, and most you should know that the cos of 45, go to your right angle triangle with a 45 and a 45 and a 90. It's a nice isosceles triangle. So the tan of 45 degrees is that over that, which is 1 over 1 or 2 over 2 or 3 over 3, which is 1. Using Pythagoras' theorem, that's a root 2. So the cos of 45 is 1 on root 2. So here we've got a 1 on root 2, and we've got root 13 on root 2. So there's the length of that, which we could go to decimals, but I'm not wanting to go to decimals, I just want to leave it as this. Or maybe I could do this to it. If I times it by root 2 on root 2, root 13 by root 2, if you don't understand, with thirds or irrational numbers, you can multiply the insides. So that's the square root of 26. Multiply the insides is root 4, and root 4 is just 2. So it's root 26 on 2. You could work it out pretty easily. Now, instead of using that formula, so if you go back to this formula, A dot B equals the magnitude of A by the magnitude of B by the cos of theta. There's A cos theta. There is, get rid of that, there's A cos theta. So if I make A cos theta the subject, you'll have A dot B divided by the magnitude of B. So the other way of calculating it is A dot B divided by the magnitude of B. So we've moved that across to here, and we've got the magnitude of A by the cos of theta. So there's the method of calculating using angle, the angle in between. This is one with just the vectors. No angles, all you know is the vectors. So we know we want to get root 26 on 2. Let's have a look at the formula. I'm going to write that 2i 3j as 2, 3. You can write vectors this way, or you can write it that way. I like this way once you get used to it, because it's much quicker to work out and less mistakes. This one's 5, 1, so I can go by 5, 1, dot product, and I divide it by the magnitude of B. Now the magnitude of B on this one is the Pythagoras theorem for 5 and 1. So Pythagoras theorem for 5 squared and 1 squared. Let's have a look at what we've got. Dot products, I'm not going to go through dot products in full. 2 times 5 is 10, 3 times 1 is 3. You can watch other videos on that, I might have some. So, and then down the bottom here you've got 25 plus 1, which is root 26. So you've got 13 on root 26, and you go, oh, it's a different answer to that. And you go, no, it's not. This is what I talk about, times by 1. So if you want to multiply by 1, you multiply by root 26 on root 26. Why? Because it turns out really nice and rearranges that into that. Let's have a look how it does it. The bottom's easy. Root 26 by root 26 is just 26. And on the top we've got 13 square root of 26. Now, if you're okay with the 13 to 26, 13 into that goes twice, and you've got root 26 on 2, and go, woohoo, we've got the same answer for that. So in brief, you can get the scalar projection using the angle, where you're using cos. So that's this one here, the magnitude of A you're projecting onto the other one, using the angle in between and the cos of it. Or, if you know the vectors, you can go to multiply the two of them. Oh, we made it. Hopefully then I'll get on to doing vector projection once you get the hang of scalar projection. Thanks. If you're enjoying it, spread the word, tell your friends. Word's getting out there. I'm getting a lot of positive feedback. Thank you. Oh, and if you get a chance to subscribe, that's even better.